Hello, everyone. We're going to do some energy questions. There's actually two different types of energy questions, and I'm going to go over the two different ones. A lot of people get confused to which technique to use, and so hopefully this lesson will help you sort of figure out which is which. So, again, there are two different types of energy questions, and the first type is an input, or you add energy into the system to calculate the new output energy. The second type is conservation of energy idea, where you have to look at many objects or energies in the system and the energy remains constant. And so it just transfers form. So energy is not created or destroyed, but it remains constant and it changes form or type. Okay, so let's do our first example of type 2. Hi. So here it is. This is actually the first example of type 1, not type 2. So type 1, this is when you're inputting the energy and you're going to calculate the output. All right. So here we have a box that's traveling at 5 meters per second. So it's already sliding across the floor. All right. And you decide to push the box some more. All right. So it has an initial velocity of 5, and you're going to push the box 12 meters with a force of 50 newtons. Now there's friction on the ground. It's kinetic because it's sliding of 0.2. Which is the coefficient. What is the new speed after the box has moved 12 meters? All right, so let's draw this out so you can visualize it a little better. So here is your box. All right, it is already moving at 5 meters per second. And let's figure other things. We're going to move it 12 meters from here to there. And the coefficient of kinetic friction is 0.2. Okay. So when you do this type of question, what's going on is you're going to put in the energy, and the energy that you're putting in is the applied force in this case. But also don't forget there's energy being taken out of the system due to friction, because friction is slowing things down. And so we have friction pushing back. All right, and the acceleration is obviously going this way. It's going to gain a speed, and you have to calculate that new speed, which is right there at the end of 12 meters. So when you actually write out your energy equation, it will look like this. So I'll bring the picture over here. Perfect. And so it will look like this. You need the energy from the applied force. That's you're inputting that energy. You're going to take out some energy because due to friction, it's going to slow down. And that new energy output is going to show up in terms of kinetic energy, KE. And that's the equation that you will use. You'll notice this, you're making up the equations just like you did with those force equations. Okay, so let's figure this out. You have the applied force times the displacement, that gives you an energy unit, minus the force of friction, again, times the displacement, and then that will give you the kinetic energy. Now keep in mind it's going to be v2 minus v1 because it has an initial velocity. If it was starting from rest, then this would be 0. Okay, let's plug everything that we know. We know that FA is 50, and we know the displacement is 12, but we don't know what friction is. So that you'll have to go back to your dynamics unit. All right, so let's go back to the dynamics unit. Remember, this is Fn, and over here is Fg. All right, and vertically it's 0 because it's not going up or down. And let's figure out what Fn is, because you need Fn to calculate Fg or Ff. So remember, the force of friction is equal to mu Fn. All right, so now that you know this, but you know Fn equals to Fg because A is 0 vertically. So now I know that this is going to be mu Fg or mu Mg would be my formula. All right, so let's plug that all in. So this is going to be mu Mg times the distance. Don't forget that distance. And then we have the box is 10, and then V2, we don't know. And then V1 is 0. Okay, so let's continue filling everything out. So this is going to be 0.2 times 10 times 9.8 times 12 equals a half times 10 V2. And so then now we can figure out what V is, and that is going to be 9.9 meters per second. And that's how fast the box is going after you pushed it, which makes sense because you are pushing it, so it should go faster than 5 meters per second. Oh yes, that's what I forgot, 5 meters per second. It's not 0. I apologize. Reading my notes incorrectly. There you go. All right, so now this is going to be, and it should be. Okay, so there you go. V1 is not 0. V1 is actually 5 meters per second, and this is the correct answer. All right, let's do a type 2. Type 2 is conservation of energy. All right, and I'll write that down. This is the conservation of energy, which a lot of you probably learned in chemistry as well. Basically, the energy before equals the energy after. So there is no input energy in this case. No input energy. It's just changing forms. So basically, the energy before must equal to the energy after because energy is constant. All right? Constant energy. All right, so that's the type 2. So I have a roller coaster here, and I would have loved to take you to Canada's Wonderland, but of course, unfortunately, that's also closed due to COVID. But we can always do, physics questions because that's equally as fun, right? Anyway, so here is your roller coaster. We've got the energy before, so it's stored in gravitational energy, and you know that it's about to fall or release that energy into kinetic. The energy hasn't changed. So here we have the roller coaster with a certain height. It's going to fall, and what I like you to calculate is basically, let's break this into parts. Part A, let's calculate the speed right here at the bottom, and then also let's calculate the speed right here as well for part B. Perfect. Let's give this a little speed over the edge, okay? Because usually with roller coasters, they kind of like slowly take you over. The only one that I know of that doesn't, it would be the Yukon Striker, and they kind of hold you there to make it more scary for you. And let's put a mass of 1,000 kilograms on there. Perfect. Okay, so let's do part A first. Part A, we have the energy before equals energy after. So energy before equals energy after. The energy before here is all completely gravitational, and you have a little bit of kinetic energy. So mgh plus a half mv squared. That's before. Now after would be this part over here, and it has 0 height. So it lost all its gravitational energy, but it turned into a speed. So this here is going to be the speed after. Okay, so this would be V2, and this one here would be your V1. All right, let's plug it in. You will notice the mass cancels out. Okay, because if you actually factor out the masses, you've got a m on this side, m on that side. Each term has a mass, they all cancel out, which is really convenient because with roller coasters, it doesn't matter how heavy or how light the people are, it will still work, which is kind of neat. All right, let's continue. 9.8, the height is 15, plus a half. The initial speed is 5 meters. And then your final speed here, you're trying to figure out. So V2, we're going to calculate it to be 17.9 meters per second. And that's how you do part A. Let's do part B. Again, energy before equals energy after. So the energy before hasn't changed. This part is still the same as over here. So I'll just write it out. So it's identical. However, now in part B, you have a height. So some of that speed went back to giving the roller coaster a height energy or gravitational potential energy. So we do need a new height. So instead, this would be H1, your initial height, and this here, H2, would be your final height. And then, of course, your final speeds, all right, which is the kinetic, because it is still going to go over. Okay, again, this is very convenient. We have the masses that do cancel out. Perfect. And then let's do it. 9.8 times 15. So this section before is identical to this part because the energy is constant. The total energy here, that's what that is. Plus a half, and then we have 5 squared. Okay. Now, the second part, we have 9.8. The new height is 5 plus a half, and then you're trying to solve for the final velocity. When you work it all out, it's going to be 14.9 meters per second, which makes sense because it should go slower because some of that energy went into giving the roller coaster a height.